This is RD Sharma Solution Class 12. Chapter 3 Binary Operations. Exercise is 3.5. Question number 6. For the binary operation into 7, x7 I'll call it, on the set. So whenever we do A and B operation with x7 or into 7, we'll multiply them and take the modulo, the remainder of 7, division by 7. The set is given as 1, 2, 3, 4, 5, 6. So what do we have to do? There are 6 values in this set. We have to compute 3 inverse x7 4. What does it mean? 3 inverse. First we'll try to find out the 3 inverse. What is the inverse? That is, when we multiply 3 with this value and then take the modulo of 7, that is division by 7 remainder, it should come it should come what? Okay, so first we have to make the table x7 1 2 3 4 5 6. I'm writing 1 2 3 4 5 6 here, and I'll just take one of the values just to let you know how we are going to compute it. So 4 and 5 I'm taking 4 x7 5. So just multiply 4 and 5, it will be 20, and then division by 7, but we have to take the remainder. So 7 here 20, so 7 2s are 14, 6 is the remainder. So write 6 here, 6 is the remainder. So all other things, all other values you will be able to make it for the composition table. Okay. Now coming to the identity element. What is the identity element? The identity element is, just see the rows. What are the rows which are common to the first one? So if you see the first and second row are same, identity element means when you multiply or you operate that certain value with that identity element, that element should come back. Okay, the first and second row are exactly same. The first and second row are exactly same. And when they are operated with what number? 1. So it's quite clear that the identity is 1 here. Okay, now identity we got. So the inverse, first inverse of what? 3 and operation of x7 with certain value, that is going to give you 1. That will be 3 inverse. So what value in the 3 column or 3 row is 1? 5. When we operate 3 with 5, you get 1. So the inverse of 3 is 5. Okay. So 5 x7 of 4 now. 3 inverse is 5. And now we are operating this with 4. Remember, identity we just found. Then we found out the 3 inverse, that is 5. And 5x4 is what? We already done it here. Okay. So what is this? See. It is 5x4, 5 4s are 20, 20 divided by 7, the remainder is 6. So the answer is 6. Question number 7. Find the inverse of 5 under multiplication modulo 11 on Z11. So when the set is not given, you have to write all the values, the modulo, after that whatever number is there, that has to be written. For example, here we have x11. So the set will be, we'll take it from z, that is integers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you count them, it's going to come as 11. So this is how we are going to write. And you may ask question, why it is not negative? There is no negative here. Okay, so 1 to 10 here, 1 to 10 here. 0 doesn't count because 0 ultimately will give you 0. So I'm not writing that. So Z always includes 0, but I'm just not indicating it because it will just, the space I'm just reducing. Okay. So 1 to 10, 1 to 10, all these we are going to write. I hope you will be able to do the x11 multiplication and then 11 modulo. Will you be able to do it? Okay, all these entries are fulfilled. I hope that you will be able to do that. Now question is the inverse of 5. So inverse means when we operate 5 with certain element, that should give you an identity element. How to find the identity, as we just saw, is 1. Why? Because the first and second row are exactly similar. The first and second column are exactly similar because the operation is with 1. So identity is 1. So 5 operated with certain value should give you 1. So in the 5 row and 5 column, just see where 1 is coming. 9. When 5 is operated with 9, you are going to get 1. So 9 is the inverse. 5, 9. How do you get? See 5. I'll just do it. 5, x, 11 and 9. So 5 9s are 45. And you just divide it by 11. 11 4s are 44. You get 1 as the remainder. And that is true. Because 1 is our identity element. So first you have to make the table. Okay, I'm not making the table because we have known how to make the table. Then you have to do all this. That is, the inverse through this table is simply where 1 is coming. Question number 8. Write the multiplication table for the set of integers modulo 5. Okay, set of integers modulo 5. So we have x5 you will write, and I just told you where it is not given anything, since it is already given integers, just start with 0, 1, 2, 3, 4. We don't go up to 5. Okay, 0 to 4. So just 0 to 4 row and column. You want to include 0, it's okay. You can include. And then I'll just show you how these values will come. I'm taking an example 2 and 4. So 2x5 4 is 4 to the 8, multiply them and take the modulo of 5. That is 5 divided by 8, 3 will be the remainder. So you have to write 3. All other values you have to put. I hope you will be able to do it because there is nothing inverse or identity being asked here. Question number 9. Consider the binary operation star and O defined by the following tables on set S equals ABCD. S equals ABCD. The first and second is given. Show that both the binary operations are commutative and associative. Write down the identities and the list the inverse of elements. So let me just make the tables. So first we'll start with the star one. A, B, C, D. Here also A, B, C, D. Let me try to draw the table. You know how I draw, because the lines I cannot draw that much parallel, nor my handwriting is so good. I'm still trying. And what are the values here? We have A, B, C, D, B, A, B, C, D. Then you have B, A, D, C. Then C, D, A, B, is here C. So this is how your table is given. You can also refer to your book. So this is the table, and we are going to solve this question through table only. Okay. So we have to show that both the binary operations are commutative and associative. We'll start with star. And write down the identity and list the inverse of elements. Now the first line and the second line are exactly similar. First row, second row are similar. First column, second column is also similar. And when they are operated with A, then only they are similar. So we know that the identity element is your A. Is clear? Clear? Identity element, will do the associative and commutative part, but first let us see the identity element. Okay. Now this, when we operate two values, you should get A. That is how we find out the inverse. See, wherever A is coming in the table, just see there. When A is operated with A will come. When B is operated with B, A is going to come. A is the identity element, right? And B is operated with B, A will come. Then we have the A inverse is A, that means B operated with B, A will come to this diagonal. All the values on the row and column which are intersecting in this diagonal are going to give you this value. B star B is A, so B is the inverse of B. C star C is equal to A, so C is the inverse of C. D star D is equal to A, so D is the inverse of D. I hope you got the idea. First we found the identity element as A. So A inverse is A, B inverse is B, C inverse is C, D inverse is D. Now coming to the associative and commutative. We'll start with the commutative. Now how this is commutative? Commutative is when two values you just operate. A star B should be equal to B star A. So just see in the table if A star B is equal to B star A. A star B is B and B star A is also B. That is equal. C star B is D and B star C is also D. And D star C is B and C star D is also B. What do you get? This is commutative. So you have to write all this, okay? I'm just telling you from this table how do we find out. Okay, coming to associative. Associative, let us take A star B star C. So this is operations. I'm saying star, it is operation actually. A star B star C, so we'll do A B first and then B C second and try to find out whether equal or not. A star B is from the table is B star C. A star B star C is what? B and C gives you D. Now B star C, B and C intersection is D, and A star D is again D. So D is equal to D. From here, it is quite, we are confident that the star is associative. Now the second part is almost similar here, and we have to do the same thing: commutative, associative, then identity element and the inverse. So what do we do? Are you able to do it? Let us do it. Okay, let me make the table first, and we will do for this table also, for this operation also. So ABCD here, and again ABCD, the operation. So this is how we have to make the binary operation table, or you can call it as a composition table also. ABCD. Okay. Now let us see A here. Means you can just refer to this table which is given in your book and just see when the two rows are similar or two columns are similar. When the two rows and two columns are similar, that means the operation with that particular value in that row or column is your identity element. That by now you have known. So let us, previously we saw the identity and inverse. We'll start here with the commutative and associative. So A star B or A operation B operation A, whether they are same or not. A operation is A, B operation A is also A. So it's quite clear that A is equal to A. You can take any other. D operation C and C operation D. So D operation C is B and C operation D is also B. They both are same. So it is quite commutative. From the table, you have to write all these, okay? Now coming to associative, let A operation B operation C. We try to see whether it is equal to A operation B operation C when we take them pairwise. That is AOB first and BOC later. So A operation B is A, AOC. A operation B operation C is what? B operation C is C. So A operation C, they both are same. A operation is simply equal to A only. So A equals A. Now this shows that it is operation is associative also. Now you see what is the identity element. See the row or column. Identity means when we operate any value with this identity element, that value should come back. So if you operate this B, say with operation with any element, that is, we'll just find out the identity element, B should come. So if you see here, the first row, this first row or first column, the first column and third column are same, and first row and third row are same. Okay, the first row and the third row, they're exactly same, and they are operating with B. So identity element is what? B here. The identity element is B because of the operation is, or you can say just the intersection you can take. The same row and column, just take the intersection, you'll get the identity element. So A operation B is B. A from the table I'm saying that the identity element is B. When we operate anything with B, A should come back. So here you see in this table, B operation with what B should come. When we should operate A with this identity element, A should come. And we know that the identity element is B. Okay. So B operation B is B. B operation B is B. So B is the inverse of B. C operation with D is what? B. So this D is the inverse of C. Okay. So this is how D inverse is C, C inverse is D, and B inverse is B. I hope you have got the idea. So in the identity element is B. Identity element is simply when you operate it with any element, the value should come back. So you just have to see in row and column at what point that value comes back, and that is going to be the inverse. Okay. This is question number 10. Define a binary operation star on the set 0, 1, 2, 3, 4, 5 as A star B, A plus B, A plus B. This relation is given, A star B is equal to A plus B. If A plus B is less than 6, A plus B minus 6 if A plus B is greater than or equal to 6. And what is the set? Set is given as 0, 1, 2, 3, 4, 5. This is the whole set. Now one or two value I am going to tell you because this question we have already done. So let us take certain value. Two values I am going to take. One will be greater than 6, one will be less than 6. So first you have to write the star 0 to 5 here, 0 to 5 here in row and column. So I am taking just some random value like 1 and say 1 operation 3. Why I am taking 1 operation 3? See on the left there are other operations also. This is how we are going to fill the value. So 1 operation 3. What do you get? 1 operation 3 is, first we have to add them. So first we have to find out A plus B, 3 plus 1. Now this 3 plus 1, 4 is less than 6. It is less than 6. When it is less than 6, what does it mean? It means you have to write here A1, this A plus B only. So I am writing 4. And then we will take another example. Now I will try to take certain values so that we add and it should be greater than or equal to 6. So 5 star 5 is 5 plus 5. It is 10. 10. So it is greater than or equal to 6. When the value, the addition A plus B is greater than or equal to 6, then we have to subtract a 6. That is, we have to write A plus B minus 6. So 5 plus 5 minus 6 we have to write. That is 10 minus 6, you are going to write 4. So in 5 or 5 intersection, you are going to write 4. I hope you will be able to make the table. Okay. Now let us come back to actual scenario here. Here we have to find out the identity element, which is of course 0 is the identity element because plus addition is going on here, and inversion. So 6 minus A is the inverse of A that we have to find out. So just see the row and column where the two rows are equal. The column where both rows are equal and both columns are equal. So if you see the first row and second row, they both are equal. If you see first row, first column and second column, they are also equal. That means when the values are operated with 0, there is no change. That is why we can easily say that 0 is our identity element. So I is equal to 0 because we know when the value will be operated with this 0, it will come back. Now coming to inverse. So inverse, we will take two cases. Identity element, I just told you it is 0. So in order to find out the inverse, we will take two cases. One will be a plus b less than 6, one will be a plus b greater than or equal to 6. See, a star b equals 0 because 0 is the identity element. So we have to find out b. Okay. So the cases which I was telling you, the case 1 will be when we take the values which are less than 6, when we add them, when we take the values which are greater than 6, greater than or equal to 6. So first a star b, the first case will be a plus b is less than 6. In the second case, a plus b is greater than or equal to 6. Right? So a plus b is less than 6. What does it mean? It means a star b is equal to e. B is, a star b is what? A plus b. And this has to be equal to 0. A star b is given as a plus b when it is less than 6. When it is less than 6, in the question it is given, it has to be a plus b. So a is equal to negative b. But in the question there is no negative. The question, the set is also not negative. So this is not possible. Coming to case 2. Case 2 is a plus b is greater than or equal to 6. So when a plus b, that is a star b is equal to e, a star b will be defined as a plus b minus 6. In the question it is given, if it is greater than or equal to 6, it will be a plus b minus 6, and that should be equal to what? It should be equal to 0. So we have to find out b. B is the inverse. So b will be equal to 6 minus a. So b equals 6 minus a. 6 minus a is the inverse of a. Okay, this is all about this exercise 3.5. Thank you so much. Take care of yourself.